Assalamualaikum. Hi, my name is Nusabila Matiswa Haimi. My metric number is D2018108310 and my current number is B19B19. Today I would like to continue our presentation on chapter 3, and I would like to present about cones. As a previous slide is mentioned that cones is a color sensitive cells in our eyes, and the cones will absorb light and send the signal to the brain to stimulate the information. Human beings have three types of cones responding to different wavelength of light, which is short, medium, long wavelength. The range wavelength not actually red, blue or green. The third one is sensitivity, determined by the degree to which each cone types are stimulated. The spectrum is encoded into the three values that correspond to each type of cones, which is the chromatic models. Chromatic vision. Human and some primates are trichromates. The color blindness results when one cone system is compromised or is broken. It has many types of color blindness. I will explain later. The third one is mammals are mostly dichromates, with some mammals is monochromates, and many birds and marsupials are tetrachromates. Marsupials is the animal which has a pocket in its body like a kangaroo. Some human females are said to be tetrachromatic. It means the females, in our real life, and we know that females can distinguish or can differentiate more colors than a male, so that's why it's said that some human females are said to be tetrachromatic. And rose are lower intensity light receptor and only kick in a low light situation. On the previous slide, it's mentioned that the rose cannot distinguish colors sensitive to low level of light, which is night vision. This is a color vision differently. The first pupils are one's normal vision with a normal vision. The second is the Dutton, and third one is Proton. Dutton is when someone cannot accept or cannot distinguish color of green, while a proton is a person cannot accept a color of red. There are many examples that I put in this slide. Next is color perception. What is color perception? Color perception is the brain sees due to the cone's response. Its different spectra sometimes appear at the same time. The two graphs is actually a same graph. It's not a same graph, but it looks like. Perceived color. The perceived color means the light from the most source of a distribution of wavelength, and enormous variety of spectra is perceived by the eye as having the same color. The third one is conversely, two objects of the same color may appear different to the different observer or when viewed in the different condition, which is metamerism. As a conclusion of this slide, it says that sometimes the object can appear in a different color in the different source. Like example, the source one is the lamp. The second is a sun. Both is the same. Both balls are the same, but it can be a different color because some object will appear different color when it under the different source, because the different source have a different wavelength. Next is representing color. How can we describe the color. Ideally, every color should be described uniquely in some numeric way. Okay, as we know, there are many types of color in the world, and as we can see on the slide, there are many types of color with their own names and codes. And when we want to use color in our computer, it always comes with a different coding. And when we substitute the code, uh, one numbers in the code, it will represent the other colors. So it said that the color should be described uniquely in a numerical way. Okay, dominant wavelength theory. What is dominant wavelength theory? Dominant wavelength theory is capitalized on the variety of spectra that produce the same perceived color. Specifies a spectrum having this simple shape. This is a graph that shows the spectrum. Okay, luminance. Luminance is the total power of light. This is how we can calculate luminance. And second one is hue, the location of the luminous wavelength, the color of the main pure light present. Hue color can we get from the wheel color, which is blue, green, in color wheels actually, the color wheels. The third is saturation. The saturation is the purity of the light, is the percentage of the luminance that resides in the dominant component. This is how we calculate saturation. Dominant wavelength, luminance, and saturation fully defined in a color. This is how we describe or how we use graph as a this is how we use a graph to describe the color. Okay, in this slide I put four different picture, four different color, hue, saturation, and lightness. The biggest picture is the how we get in final project when we compile the three types or three different types of picture. The first one is lightness, second one is saturation, and hue. When we compile it together, it will get the biggest picture. Okay, that's all for me. Thank you.
Assalamualaikum and very good evening to my lovely lecturer, Dr. Kim, my beloved friends and colleagues. My name is Muhammad Munif bin Abdul Manaf. My calling number is B2 and my metric number is D20171076736. Okay, I'm from group 3, so our group presenting about images, geometry, and color. So now I'm going to explain about my part. First, what is image? Image is a visual representation that allows us to perceive data. Okay, representation. There are two key low-level components of representation. First, geometry, and then color or intensity. Representation possibly can be high-level issues such as mood, realism, quality, aesthetic, and clarity. Yeah. Okay, now we are going to move to the next part. Sorry if it takes a little time. Okay, there are two alternatives of image. First, model geometry. model geometry, then apply color to geometrical primitives, or second, subdivide the display space into a raster, then assign colors to pixels. Okay. So first, the first alternatives, geometry. So what is geometry? The field of knowledge dealing with spatial relationship. So to describing shapes and efficiently and ambiguously is difficult enough in everyday life. So how do we do this digitally? The answer is CGI. Okay, elements of CGI. The important is we may need to compromise a little bit about CGI. We need decomposition, simplification, and abstraction. There are four usable primitives that are modeled mathematically in CGI. First, raster image or sprites. Second, text. Third, points, lines, polylines, or polygons. And lastly is curves. So now I'm going to tell you about the first primitive of CGI, raster image. So what is raster image? Raster image is an image made up of many small regularly placed cells called pixels. As you can see here, this is all pixelated. When we zoom to the eyes, you can see the pixelated image there. It may look like a square, maybe we call pixel. Okay, so raster image also stored as an array of numerical values commonly called a pixel map, pixmap, or bitmap. This is the raster image storage. Usually we use it bitmap, this is Z0 and 1. When it has no color in the box, it equal to 0. When it has color or maybe black in there, it will be 1. As you can see, 0, 0, 0, 1, 0, 0, 1, 0, 0. Okay, so this is the color raster. There are three components in color raster: red, green, and blue. So what is sprites? In computer graphics, a sprite is a two-dimensional bitmap that is integrated into a large scene, most often in 2D video games. The examples of video games I can tell you is Mario, the old Mario, not the now Mario, right? Super Mario. You can see the Mario is pixelated, so like 2D shape. Okay, maybe you can see here the zombie can move. Okay, so who developed sprites and where it were developed? Sprites were developed at Texas Instruments by Daniel Hillis. So we move to the next primitive, which is text. So text is traditionally each character stored as a small raster. Why it has raster? So as you can see, it might be a pixelated image. So the equal of this image, it become letter V. Okay, so true type fonts are stored as curves and vectors, usually smoother to look at in a varying solution. Some devices distinguish between text mode and graphics mode for text. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz bin Salehon. My metric number is D2017-107-6735. My calling number is B1. Okay. As you can see from the slide 36, here they show about the lights, the saturation of the lights, hues, saturation, and lightness. This is show a lot of distribution of wavelength, and the next slides show about how HSL double code the light, the saturation, and the hue. Before I proceed, hue is one kind of color or a shade, visible hues and saturations. The eye can distinguish about 128 hues and about 20 different saturation depending the hue. As you can see from the slide, theme, they got three: tint, tone, and shade. The tint is pure hue plus white. This is kind of hue, pure hue and white. Tone, pure hue and plus gray. And the third one, shade, pure hue plus black. So what the shade is, totally you can see the black color. Next is the RGB model. RGB model is an additive color model based on the primitive red, green, and blue. Primitive. An additive color model based on the primitive red, green, and blue, like primary color. Yeah. From the picture, from the diagram next to it, you can see the primary color is my red, blue, and green. And then when it's mixed blue and red, it become magenta. The blue and the green construct a cyan color, while the red and the green will combine and will produce a yellow color. Meanwhile, after all of the color, you can it will appear like a spot, the white spot. Okay, most commonly used in computer graphic, approximates humans visual response fairly well. So this model very helpful to approximate human visual response fairly well, so they can differentiate which color it is. Okay, additive color, this is what just I explained just now. CRT system employ additive color mixing. So red plus green equal to yellow, red plus blue equal to magenta, red plus blue, green plus blue equal to cyan, red plus green plus blue equal to white. It's simple as that. We can get intermediate color mixes by varying the intensity of each of the three primaries, like orange 100% red plus 50 green plus 20 blue. They giving the portion to each of the color. So solid spectral colors are optically mixed by being placed closely together or by being presented in rapid succession. Two or more colors perceived as being one. Two or more colors perceived as being one. So that's the conclusion. So next is the digital color, RGB color. Digital color means that they use the bit, 24-bit color, 8-bit color for each primary. So in each of the primary, they have three primary color, red, green, and blue. So every each of the color they given to 8 bits. Okay, and then 0 to 255 in unsigned integer. Many graphic packages, however, would use real numbers ranging from 0 to 1. Example, float. You know float? The float is when we using in the coding the 32-bit color. They have two, like this is 32-bit, 8 bits per color plus 8 bit for transparency. Then 48-bit color, 16 bits for each primary for editing high color resolution as is important. So the color used in digital are using by bits. There are 3 kind of bits. Alright, this is show how the colors. The first one is the mixed one. The second, the third, and the fourth is showing us the primary color. And then next one is RGB color space. This is how like 3D objects space are with using the color, you know. This from this slide you can see that they use 3 axes to represent the color. So the green color, the one to the right are using the green as a green color for the axis, and to the left using the red, and to the up horizontal one using blue. So from that they show us how the combination happen and mix from to become another color. So that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Izzat bin Muhammad Fakuruzi from 8020 course. Okay, today I'm going to present about chapter 3, which is the image, geometry and color. Okay, let's go to the slide. Okay, I'm going to present about device dependency. As you can see, we can see cube shape over there, which is said to be RGB space 2 and RGB space 1. Okay, so unfortunately the choice of red, green and blue can be quite different in different implementation. Okay, and then it is said to, if the phosphorus colors are slightly different, the vector space is different, so we cannot use RGB to universally define a unique color. Okay, and so we can solve it by using a device independent color space. Okay, next about CIA standard. What is a CIA standard? CIA standard developed by Commission International de l'Éclair 1931. It is used to define color based on the 3 standardized primary X, Y and Z, which are able to produce all visible color and provide a standard difference for comparing other color system. Next, about the CMY color. What is a CMY color? A subtractive schema based on primitive, which is cyan, magenta and yellow. Okay, it is commonly used in color pre-production. Okay, next about the subtractive color. Subtractive color mixing result from selective absorption of a light wavelength. It is an overlapping layer of varying percentage of transparent primaries are laid down. As you can see, that is an example of subtractive color. When we see the ray reflected on object, the other light ray are absorbed. What is absorbed? The green one is absorbed, and the blue and the red one are reflected. And when the blue one and the red one reflected, and they combine and they produce a magenta color, and the green are absorbed. So that's a subtractive color. Okay, next about CMYK. Before this we heard CMY, and this one is CMYK. We add a new word, which is the K. Okay, black generated by mixing the subtractive primaries is not as dense as that of a genuine black ink. Okay, there are 4 color printing uses black ink in relation to subtractive primaries, which is cyan, magenta, key, which is black, and yellow. And this is a color model that you can see. Okay, next about rasterization. Rasterization is a line drawing algorithm render mathematically ideal of a line onto a raster storage, which is similar technique of a curve drawing and shape filling. Okay. Next, about the aliasing. Anti-aliasing process effectively blurred edge to soften the boundaries. As you can see, that is the some example which we use to process effectively blurred edge to soften the boundaries. Okay. Okay, the last one is about the resolution. When we rasterize an object, if it effectively bind them to a certain raster level of detail. As you can see the example, when we raster 10 dpi, we can get a better resolution. We can like 300 dpi or 72 dpi. Okay, that's all from me. Thank you.
Assalamualaikum and very good morning. So today my name is Hamizah binti Sahib, D201810832115. So I'm B20. So today I'm going to present about our topic, geometry and color. So in this topic we have a lot of graphic files. For example, we have bitmap formats, vector formats, metafile formats, scene formats, animation, multimedia, and hypertext and hypermedia formats. So a graphic file contains data that is rendered to or relies on a hardware output. Rendering involves processing the graphic files to suit the constraints of the graphics output hardware. So we move to a few of graphic files. First is vector image. Vector image is decomposed into simple geometry objects such as text, and it contains mathematical description of image elements rather than pixel values. And the quality of vector image is better compared to bitmap image. So bitmap image is sometimes we call it as raster files, which it contains an exact pixel by pixel. So the picture of bitmap image is quite blurred. The third one is metafile format. Metafile format, it contains both bitmap and vector data in a single file, and it used to transport bitmap or vector data between hardware platforms. So the example of metafile format is CGM, WPG, and PICT. Next is scene format. Scene format is it was designed to store a condensed representation of an image or scene. For example, exploding of mountain and many more. The second one is animation formats. Animation formats, we can see it as a simple one like flipbooks that rapidly display one image superimposed over another to make it appear as if the objects in the image are moving. It displays rate of 10 to 15 frames per second, is typical for cartoon-like animations. For example, we have TDD and TDDD and TTDDD, that 2D or 3D image. Next is multimedia formats. Multimedia is ongoing program of moving pictures and associated audio. We as a student, actually we also use this type of files that we can store any data or different types in the same file. So the example of this multimedia formats is MPEG. And the last one is hypertext and hypermedia format. Hypertext is text that display on a computer or other electronic with reference, like hyperlink to other text that reader can immediately access. It can be accessed by a mouse click. And hypermedia is combination of hypertext and multimedia. So the example of these formats for hypertext and hypermedia is GIF, JPEG, and MPEG. So we move to display hardware. We have two types of display hardware. First is hard copy devices such as printers, plotters, or speakers. And the second is transient displays like LCD monitors, projectors, and CRT monitors. This is the picture of cathode ray tube, color system, and shadow mask. That's all from me. Thank you.
Assalamualaikum guys and very good morning. My name is Abdul Aziz bin Ahmad. I'm from group 3. My metric number is D20171071076753. My calling number is B4. I hope you guys have a great day. If not, it's okay. It's just a bad day, not a bad life. Okay, now I'm gonna continue to present the chapter image, geometry and color. So let's proceed. Okay, points and lines. Points are usually described as vectors, either x or y. 2 points make a line segment. Several lines of segments make a polyline, while polyline can be filled and combined to make more complex shapes in 2D or 3D. Curve. Curve is some simple shapes can be fully described by mathematical equation. For example, circles. For more versatile everyday shapes, we commonly use a family or curve called splines. What is splines? Splines are relatively easy to mold into desired shapes. Now we move to color. Color is a sensation which occurs when light energy incident on the retina is interpreted by the brain. Wayne Wayton had said, color is a Wayne Wayden have said that color is a psychological interpretation, not a physical property of light itself. Color in computer graphics. How we see color? Color vision. The response of the visual system to color or color appearance. How to measure color? Colorimetry. Then computer graphics is interested in. First is color vision perception, and the second is color reproduction, and the third is color synthesis. The process of seeing color. First, light enters the eye as a spectrum of colors distributed by wavelengths can be represented by a spectral density function. Spectral density impinges on retina and is picked up by light-sensitive cells. The retina of the eye is its light-sensitive membrane containing two types of cells. The first cell is cones, color-sensitive cells, and the second one is rods, which cannot distinguish color nor find detail but sensitive to low level of light. For example, night vision, visible light. Light is an electromagnetic phenomenon like television waves, infrared radiation, and X-rays. So we can look over here with wavelength and frequency. Now we move to pure spectral light. The human eye responds to light with wavelength between approximately 400 and 700 nanometer. Some light sources emit light of essentially a single wavelength, for example lasers. Some spectral densities for pure spectral light and how we perceive them. As we can see from this graph, it shows the horizontal is show the wavelength and the vertical is shown spectral density. Okay, spectral density functions. In most cases, light consists of a range of wavelengths. This mixture of wavelengths can be represented by a spectral density function. Some spectral functions densities are shown to the right. Okay, we can look at the graph. The horizontal is shown the wavelength and the vertical is shown the intensity. Okay, this is the sample spectral distribution of every color. Okay, the first one is black, and the second is gray, and the third one is white, and the fourth is orange, and the fifth green, and the sixth purple, and the seventh yellow, eighth blue, and ninth red. Okay, that's all from me. Thank you.